Hello everyone, I'm Leyli Novruzova, and today I'm going to explain you the double integrals over general regions. So firstly, let's talk about what double integrals are. So double integrals extend the concept of single integrals, the function of two variables. They allow us to compute the volume under a surface or a given region in the xy plane. Okay. So before starting with the general regions, I want to briefly recap the double integrals over rectangular regions. Okay, so as you can see, we have a rectangle R, that R equals to AB multiplied by CD, and so the double integrals is defined as this formula that you will use throughout this chapter to find the double integrals of fxy over R. And if we open this integrals, we will get this formula. Okay, so I don't want to stop here. Let's go to the non-rectangular regions. So if, for example, we have this kind of region, what we can do? So to define double integrals over a non-rectangular region, we start by covering R with a grid of small rectangles that is shown in the picture as we did with the rectangle itself. But I want to explain it here. So some of the cells will lie partially outside of R, as you can see, for example, this one, and all of this. Okay, and by refining the grid, making this also smaller, and summing the contribution of the function fxy over these cells, we form the Riemann sum of Sn. Yeah, this is the Riemann sum. This is the formula where this delta AK is the area of all kth rectangle. Okay, and it as the partition gets thinner, the Riemann sum Sn approach to double integrals and approach to 0. So this is expressed as this formula right here, yeah, where P is a partition that approach to 0, and we get the sum of K, okay, that equals to 1 to N. Okay, so let's go to volumes. So if fxy is positive and f is continuous over R, we define the volume of the solid region between R and this surface z equals to fxy to be this formula right here, the double integrals of fxy over R. Yeah, and this is the example of this kind of object. But let's go down and I will explain you how we solve it. Okay, so here you see the object that we divide with a plane right here. So we may calculate the volume by using the method of slicing. So we take the plane and divide with it an object that is given. So we divide it with AX. And now, so firstly we should calculate the cross-section of area, cross-sectional area. So AX is equal to y equals to g 1x to 9 g x of the function xy dy. Yes. So this is the formula to find the area. We found this, and now to find the volume, we should integrate the AX by from x to A and x to B. Or x to that equals to A to the x that equals to B. Okay, so then we will get the volume as an integrated integral, and it will look like this. Sorry. Yes, and to open this up, it will look like this one. So we will use this formula in this chapter to find the volume. Okay, and here we have the same thing, but we can divide our object with a plane not only by x-axis but also by y-axis. as you can see, this is AY. And so firstly we find the area of y, AY. And yeah, I wanted to show that this is, this is the area. So it's the same thing, but firstly we find the x and the y. Okay. Another interesting thing is Fubini's theorem. So it states that that if fxy is continuous over our region, we can evaluate the double integral as an integrated integral in either order. As you can see in the first one, we have dy and then dx. Yeah. If we have that x is more than a but less than b and y is more than g1x and less than g2x, so we firstly find the integral of the dy, yeah, and then dx. But here we firstly find the dx and then dy. Okay. This is an example. So here I should sketch the region of integration and evaluate the integral. So first, let's sketch this one. So it will look like this. So as you can see, y equals to 1. So let's imagine this is 1. We will draw this line. This is 1. And y equals to, x equals to y squared. And it will look like this. So this is the region. This is a sketch. And now we should evaluate the integral. So if we calculate, it will look like this. Let me do it by myself and show you after. Okay, so now I solved it, and as you can see, first we find dx and then dy. Yeah, put 1 and 0 here, and then the answer will be this. Okay, so finding the limit of integration using vertical cross sections, and then finding the limits of integration using horizontal cross sections. So I just want to explain that we have 3 steps of finding where should we start, which integration we should do first, dx or dy. So first we should sketch. Then after that we find the y limits of integration, and then we do the x limits. Choose x limit that include all the verticals length through R. So this is the 3 stage, first one, second, and third. As you can see, first this one, then this one. So it moves like this. And we take the region from 0 to 1. So this is how we create the function, the double integration. Okay, we do the same with the horizontal cross section, but we do it from the y-axis. You can see it all moves from here to here. So as you can see, from 1 to y squared in a row to 1 minus y here. Okay, and this is an example that I will solve for you. So I should sketch the region of integration and write an equivalent double integral with the order of integration reversed. So let's first sketch the graph. Okay. Okay, so it's y minus 2. So x equals to y minus 2. We can rewrite this x plus 2. Okay, so this looks like this. Okay. Okay. So we got the graph, we sketched it. Now we should do the integration reversed. So firstly we went from y to 0. But now we should find the dy, then dx. So now we should move like this in this direction. Okay, so it will be from 0 to x plus 2. And dy will be from from negative 2 to 0. Yeah. That's it. Okay, so now purposes of double integrals. I put it so you can look at them. They're quite easy. For example, if we have c, then we will put it here. We will move it outside of the integration. Some difference, yeah, we can find separately, and then find the sum or difference. Combination, if it's more than 0 or r, it will be like this, same as here. And additionally, if we have this kind of situation, we can divide by r1 and r2, and then just add them. As you can see in this form, it will be hard to find. We separate them, and then first find the r1 and then r2. Well, that's it. Okay, this is the end of my explanation of this topic. Thank you for watching. See you.